So as per our discussion, we are just going to start to implement our convolution neural network in our artificial intelligence. So the first step of making CNN is we need to import all the mandatory libraries. So these are all mandatory libraries. So this convolution 2D, which is mainly used to handle images, max pooling, it's all our pooling steps, and flatten, which is for flattening. So the second step, as per our previous ANN, we need to initialize the CNN, and then this all the steps we need to implement: convolution, max pooling, flattening, and full connection. So let's we start to apply this in our spider. So now we are just going to implement our CNN in our spider. So from keras dot model import sequential, then from keras dot layers I am just going to import convolution 2D, and from keras dot layers I am just going to import max pooling 2D, and then from keras dot layers I am just going to import flatten, and then from keras dot layers, so now we are importing our dense. So this all the things we are just going to import. So we are importing our sequence, convolution 2D, max pooling, flatten, and dense. So after this we are just going to initiate our CNN. So as like same our variable name sequential we initiate. So now this is what our initialization is. So now this is our next step which we need to apply. So classifier dot add, this is nothing but how we are just going to make our input shape of our image. So classifier dot add, this classifier, that's nothing but our initiate step, and now add, this is we are just going to add something. So convolution 2D, this is our library, and 2 dimension we are going to handle. So 32, that's nothing but how many input shape we are planning to deal, and number of channel. So this input shape, that's nothing but we are just going to handle for 64, 64 and 3. This 2, that's nothing but the dimension, and this is nothing but a number of channels. So this nothing but a dimensions, and this is nothing but the future detector total value. This is the future detector total value, this is a dimension, and this 2 again the dimension, and this is the number of channel. We are going to activate the rectifier not to get non-negative values. So this is our third step. So when we are giving a 3D array, this is your colored array. So this image will convert into 3 dimension. One is blue, another one is green, and another one is red. So this red we are calling as a red channel, and green we are calling this as a green channel, and blue we are calling this as a blue channel. So this is converting into 3D array. Each channel correspond to 1 pixel. So black and white image which we are making here. So the next thing is, first step we need to implement this layer. So after this we need to start to again build our convolution. So classifier, that's nothing but our variable name. So convolution 2D, so as like our future detector, this is our future detector 32, and this is number of dimension, this is a 3 dimension. So comma, what we are just going to give is input underscore shape. So this is again how many dimensions, comma our number of channels. So after this we need to implement our activation function that is nothing but our rectifier. So yeah, we did our convolution 2D here. So I hope everything is now perfect here. So convolution 2D and 32, future detector 3,3, and then we are giving our input shape equal 6464 and activation rate. We just did the best. So now our next step is we need to implement our pooling. So here this is our input image that this thing we implemented. The second step we are going to import the pooling. So for to import the pooling, that's nothing but to reduce the future map. We are giving the classifier variable name add. So now we are going to add the max pooling and our pool size is 2,2. So 2,2. So based on this our future map will now starts to work. So max pooling size of our subtable, that's we need to given here. So the pool size. So the next thing is we will apply with our spider now. So now what we are just going to do here is that's nothing but our pooling. So now what we are just going to create here, that's nothing but classifier dot add. So now what I am just going to given is max pooling and then 2D. This is what our exact stuff is. Then pool underscore size equal 2,2. So now this is what for our pooling we need to make. So I am just going to run this. So we check how it's going to be work. So using our TensorFlow backend, just now my TensorFlow also got update. So let it be run. So we will go and discuss about second convolutional layer. So our second convolutional layer, that's nothing but flattening. So now we need to start to add our next step. This is your flattening. Before flattening we need to add one more convolutional layer. So this convolutional layer we did. So now we need to add one more convolutional layer. So we add our second convolution layer. Okay. So now what we are just going to do is the same classifier dot add. So the same kind of thing, this convolution 2D and this is for 32 and again 3,3 and then again activation. So in activation we are just giving relu, that's nothing but your rectifier, and then classifier dot add. So now what we are just again we need to add is our pooling step. Classifier dot add. So max pooling, it's a variable name, and then again here actually we need to make this pool size, this argument error, and here we are getting keras dot model. This is not there. Yes, this is models. Okay, so great. So now what we need to do here is max pooling. So now we need to give pool underscore size equal 2,2. This is our next step. So now we added our second convolutional layer as well. We run this. So now again cannot import ring CONV do. Okay, so here this C is caps. So I hope now everything is fine. Layers, import flatten, import dense. Okay, great. So we run. Yes. So now everything is perfect, I guess. Yes, so everything is perfect. We are not getting any error. So now we add our first layer and then we added our second layer. Now the third step, that's nothing but the flattening. So this is what flattening, all the pooling layer which is going to be converted into one single pixel. That's what our flattening step here is. So let's we apply our flattening step in our CNN. So flattening, what we are now going to do is variable name dot add. I am just going to give flatten. So this is more than enough to give the flattening step. Okay, great. So the next thing is we need to make full connection. So that's what our next step is. So in the full connection, what we need to do is again classifier dot add. What we are just going to add is a dense. So now we are just giving units equal 128 comma activation equal relu. That's nothing but our rectifier. So this is for our output. So how this full connection will work? This is we apply the flattening, our input layer, fully connected layer, and this is our output layer. So for this we need to first apply our input layer. This is nothing but complete our ANN. So now we are just apply our, we just created our CNN. Now we are just going to make our artificial neural network to predict how your image is going to be handled. So for that perspective, what we are just going to now do is we will create our full connection. So classifier.add dense. So total units is 128 we are going to use, and then now I am going to add one more layer. So the same dense, this is nothing but our hidden layer thing. So units equal 1 comma activation equal, what we are just going to given here, that's nothing but sigmoid. Okay, so now we just given all those things. So now classifier.add dense units equal to 1 and the activation is our sigmoid. So our next step we need to given here is, that's nothing but full connection we did now. So now we need to compile as like our ANN. So this compilation, what we are just going to do is classifier dot compile optimizer like our CNN. I am just giving Adam, and then now this is again we are going to get only true or false. So binary underscore crash entropy, correct. So the next thing is what we are just going to given now here again, which matrix we are going to handle, the same accuracy. So we are having a multiple matrix, that's for our advanced stuffs to make everything. Now we are just going to calculate only our accuracy stuff. So this is what our compile is. So now we just make the basic neural network stuff. So the next thing what we need to do is we need to fit the CNN to our image. So this is our basic CNN model. The next step is we need to fit our CNN like this. So this is our input image and we apply to the convolution and then pooling and then flattening, and flattening will be connected to the fully connected layer. So now we need to start with this image augmentation. So the first function we are going to use to generate this image augmentation, that's nothing but how to prevent the overfitting. We know in each and every situation where we have a new data to train our model, it will found some correlation. In few observation of our training data set, it will generalize some correlation of new observation. When one image is coming, we need to make the better correlation to perform our computer vision or machine learning. So to make independent variables and some labels, we need to find a lot of image patterns. So now we are working with 10,000 images, and that 10,000 image, 8,000 we are going to make for training and 2,000 we are going to make it for our testing data set. So here we are going to apply the data augmentation comes into play. So now what we are just going to do here, So we need to start to apply the CNN to fit with image. So now we are just going to fit into the image. This is what our next step we are going to do here. So now I am just going to given from Keras dot pre-processing dot image. What I am just going to do is import image data generator. Okay, it's done. Now the variable name, what I am just going to do is data gen, and then now what we are just going to do here is image data generator, and now we need to apply some arguments here. So the first argument, that's nothing but we are just going to apply rescale equal 1 point divided by 255 comma shear underscore range equals 0.2 comma. So now what we need to do is zoom underscore range equal 0.2 comma horizontal underscore flip. This all the things which is for to fit our image augmentation to our image. We are just fitting our CNN to our image. So this we did, the shear range, which is nothing but how much we want to implement, and then this text generator, everything will be just making here. So this is nothing but which is used to make all the correlation to be make it perfect. So the next thing what we need to do here is we need to implement our text data generator. So test underscore data gen, this is nothing but the variable name which I am going to handle. Now image data generator. So now this image we are going to generate for our data. So now I am just going to rescale my data to this calculation 1 point divided by 255. So this is the rescale which I am going to apply. So the text underscore data gen image data generator rescaling size is this. So now we need to make fit our directory. So for that perspective, what I am just going to do is training underscore set equal, the next thing is train underscore, this is nothing but our training data set which we are going to fix, training data generator underscore, okay, train underscore data generator dot flow. Based on this flow we need to work underscore from underscore directory. This is our next step. So directory. Okay, so now what we are just going to implement here is the data set. This is nothing but the folder name which I created in my thing. So this is the data set folder. Inside the data set folder I am having the training set. All this training set I already preloaded with some images. So the multiple cats image and multiple dogs image I already preloaded. So almost I am having the 10,000 data. So it started to reload it again. So we need to wait because I just click this. So why we are just loading this much of data and we are just making splitting? I already got all these images and to read all those images. Now here I am having a multiple cat image and multiple dog images. So one cat image now I am just open. So this kind of cat and dog I already open. So now when I am just going to give the input, so this kind of cat and dog like this, I just created a multiple cat and a dog images. So here cat and here we are having a dog. So total 10,000 data set. I already splitted 8,000 in training and 2,000 in testing. So now what I am just going to do is, so now when I am going to give an input in the convolution, my convolution neural network should identify the particular image is dog or cat. So the data set I am just giving training underscore set, that's nothing but my folder name. So comma, now what I am just going to given is, that's nothing but a target underscore size. This all I need to give how much target. So we already created 64,64 dimensional in our input shape. So I am just giving 64,64, and then what we need to given is a batch size. So like our previous example, here also I need to give my batch size. So the batch size is 32 I given. And now which mode I am just going to calculate, class underscore mode equal, I am just giving binary. So now we just created this training set. So this is what our training set we need to handle. This training set we created. So train underscore data generator, that's nothing but this variable name. We already created the image data generator here. So from this we are flow from directory, that's nothing but this is going to flow from this particular directory. So this is what this lion is representing here. So now what we need to do, the next step is the same kind of step, only next again we are going to do. So now we are just going to create test underscore set. This is for our test data set. We already created test underscore data generator. So now we are going to get flow underscore from underscore directory, the input function. So our next step is we need to give all this our argument. So our argument is, the first step is data set folder. I am just going to give my test underscore set, which is already I am having here. So test underscore set. So the next thing is target size, where I already created all those things. I need to give the same sizes here. So 64,64 dimension, and then again batch size. So batch size is better if we give the same thing what we given for our testing. So 32, and the class mode, this is binary, either it may be a cat or dog, only 0 or 1. So now we created our training data set and a testing data set. So the next thing is we need to fit into the data. So for this perspective, classifier.fit, what I am just going to do is training underscore set, comma, we need to fit with our training data set, right? And then steps underscore per underscore epoch. So now this epochs, how many times I want this epochs? I want 8000 times, like our previous. Epochs batch size I am going to give 25, and validation data. So validation data, that's nothing but our test underscore set data. And then validation step, how many steps I want to implement for my validation, that's what my validation steps is. So I can now going to give 2000 steps. So the more you are feeding the data, the more accuracy we used to get. So I just make all the programs be very good. Here we are just having the accuracy. So now here we are not going to give any input. Giving an input and checking, it's a little intermediate step. So to understand basic convolutional neural network, what we are simply doing here is, we are having one training data set, and here we are having one testing data set. So in training data set is the actual data set which we are going to feed into our machine. So this training data set, we already have 8000 cats and 8000 dogs. And in testing data set we having 2000 cats and 2000 dogs. So now this training data set will check how many cats and dogs are in the right prediction folder. So this training data set will go and fit with our testing data set and check how many of them are correctly right classified to cat and dog folder. That accuracy only we are going to get. So now for that we need to import all these libraries. Then this is for initiate, and then we add the first initiate folder, then pooling, then again second convolutional layer, then flattening. After flattening we need to apply the full connection. This all done. Then this full connection, that's nothing but our neural network, ANN network, and then this is our compile. So this is basic CNN, but still now we didn't give our image stuff. So our image thing we are just going to give in the data generator. So this is like how much rotation we want, and the zoom range and the horizontal flip, everything. So this is for our training and this is for our testing. So after we created about like rescale, the shear range of our image, everything once we fixed, now we are just going to apply our training data set. So variable name, this one, from which directory. We already classified the directories, data set training, and the target size, that's nothing but our predefined dimension, and the batch size. So fit into the data. So training steps per epoch, and the validation steps. Once we give all those things, now I am just going to run this thing. So now here we are getting positional argument follow keyword argument. So here our positional argument does not follow our keyword argument. This is the basic Python error. We need to check why this happened. Yeah, this is happened because I given here the bracket. So this is a positional argument. Now this positional argument, this is considered as a positional argument, and this is considered as a keyword argument. Always the first thing we should get the keyword positional argument. Second step only keyword. Here I forgot to give the equal symbol. That's why this class mode now consider that as a positional argument, but that's a keyword argument only. But to understand the keyword argument, we need to make that be clear. So train underscore data gen is not defined, but we define that with our image data set. So now why this error has happened? Train underscore data gen. So probably it's just getting this error, but we already defined this. Let's we run still now, so it will give the better performance. Okay, still we are just getting train underscore data gen is not defined. This line is not applicable. Now we need to check why. Yeah, the reason is here I give date gen, so the spelling mistake. So now it will be fine. So let's we give the E here. Okay, now this is fine. I guess now we will run. So now the batch size for 25. Yeah, so we start to run our epochs. So total 1 bar 25. Now it needs to run 8000 images belong to two classes. These two classes, that's nothing but one is dog, another one is cat. So now this accuracy score, it's actually starting from 0.50. So now we having only read only this 8000 data. Let's see how much it's going to be get. So we found 8000 image for our training, two classes, one is dog, another one is cat, and found 2000 images belong to another two class, one is dog, another one is cat. So now it will take too much of time. So my god, the estimated time is around 2 hours 44 minutes. So because to run this 10,000 images, when we are running this image, actually totally 10,000 image we need to run. So to run this much of image, we need to get the very good CPU systems to be here, otherwise it will take a lot of time. Simply from this program we will be just getting an accuracy. So how much accuracy it's saved in our training data set and testing data set. In real time, how it will happen is, when you are going to give one image to the neural network, that image will analyze the image and it will just categorize it belongs to your cat or dog. So we need to feed as much possible images to our neural network, so our neural network will start to understand about the images. See, the more images we are feeding, it will understand our data set. So here we are getting an estimated arrival 2 or 30 minutes. We can't able to wait that much hours. So simply I am just giving the overview about how much accuracy it will give. So in this thing, advanced stuff, in real time how it will be working is, some input will be given. It may be a scanner or it may be to robot. It should analyze about this is a cat or dog, or it's a bus or train, it's a bus or car. So to analyze this is a bus or car or train, we need to feed around 10,000 car, 10,000 bus, 10,000 bike, all those things. So even for this traffic light controller, our neural network based on computer vision work based on this theory only. So this theory, which is used to give the basic overview about how our neural network is work. So I simply stop. So I just get keyboard interrupt. So here we are not going to get anything, only the accuracy. So in 8000 images for 1/25, it's readed only 171 image. So from 171 image, from this epochs we got 0.57. So probably when it's completing all the 25 epochs and when it's read 8000 image, we used to get around 0.80 accuracy. So here we just give matrix accuracy. So we are having the we are getting only the accuracy. Apart from, we are having a multiple arguments to be passed in the matrix. So based on the argument which you given in the matrix, our output will varies. So this is what our convolutional neural network, which is mainly used in image analysis. So to analyze this thing, if we are having a better system configuration, your system analyze will be little speed. So the next step is, we need to get start to our RNN, recurrent neural network.